In this presentation, I will show the workflow for processing of historical aerial photograph of Northern Namibia taken in 1943 and in 1970s. These aerial photographs were purchased by Professor Emmanuel Kreki of the Princeton University History Department in early 1990s. The 1943 aerial photographs are unique because for the first time, aerial photos technology was used in capturing the landscape of Northern Namibia. At that time, the area was sparsely populated. These aerial photographs will allow the researcher to understand the landscape of Northern Namibia before the influx of refugee migrants coming from Angola in the 1970s and later because of war, drought, and political repression. The 1943 aerial photograph could be compared with those of 1970s, 1990s, and 2000, and later images to understand changes in Northern Namibia's environment over half a century. The 1943 aerial photographs were taken in the Second World War, taken by the Second World War pilots who were getting trained in South Africa to take aerial photographs so that they could use their skill in the war in Europe. The pilots have taken aerial photographs along the border of the area controlled by South Africa. The pilots were not flying the plane in a straight line, and also the altitude seems to change a little bit in some photo. The Professor Kreki and I tried to use these aerial photographs for teaching before, but had difficulty in georeferencing the large area and comparing this with other more recent images. Last year, we developed a project and applied for a Princeton University Magic Grant to process the historical aerial photograph of 1943 and the 1970s, and we were given the grant. The main goal of the Magic Grant project is to process all the historical aerial photographs purchased by Professor Kreki, totaling 1,400 aerial photos, and create the orthomosaic images. After all the aerial photographs are orthomosaicked, then we will test neural network and deep learning tool to extract features from the orthomosaicked images. So let me try to show you the workflow of how we have done processing the aerial photograph from 1943 and 1970s. So here you will see the example of two photographs, 1943 and 1970. So 1943 original size is 7 inches, but the print size is roughly 10-inch, and it's, because of that, we scan these images at 1,200 dpi. And however, on the 1970 aerial photograph, the original size is 9 inches, but print size is roughly 19-inch. And because of that, we scan this aerial photograph at 600 dpi. So this map shows the coverage of both aerial photograph, which is in a red color. And this is a sample of the 1970 aerial photograph. It's a really large. So what we have done is we have scanned the flight plane map and then georeferenced them, and then trying to understand how the aerial photographs are organized, and looking at the numbering of aerial photographs, that we can see that it seems the first row is flying from east to west, and second row is flying from west to east, and third row is flying from the east to west. So we have only 3 strips of the aerial photograph from 1970s. So after that, we looked at the aerial photograph and trying to change the direction, orientation, and see whether this is really happening. And then we looked at this waterhole and then this waterhole, and it seems like it's actually going in east to west direction. And also these aerial photographs seems to have 60% overlap, and then roughly 20 to 30% on the side lapse are there. So it's a really good aerial photograph. So then what we have done is we have done a rough georeferencing of all this aerial photograph in order to understand actually whether the georeference, the flight map is actually located in the right place or not. So we did this one georeferencing. The beauty of doing a quick georeferencing is that it allows us to create a mosaic images of those georeference images. And then what we have done is we have used the footprint of those mosaic images table and to open that up. And then we're trying to use that table in order to create the frame data, or what we call exterior orientation table. So you can get the location in XY coordinate system and associated with the file name, which is this and that one, as you can see. Now, in order to create the exterior orientation table, which is needed in order to go through the workflow of creating the orthomosaic image, you not only need the center point, but also need the elevation where the plane is flying, which you can get it from the flight map, plane map itself. So altitude is there. So we converted them into a meter because the exterior orientation table units need to be in meter. Then beside that table, you also need the camera information. So you can get the camera information also from this flight map paper. And so you can see the camera information as well as the focal length. So the camera information and focal length, all the information related to the camera, you need all of them in a micron unit. So what we have done is, beside getting the camera information and the focal length, we also need to figure out the resolution part. So this is 1971. The original size of 1970 is roughly 9 inches, but the printout is roughly at 19 inches. So we changed the resolution to 1200 dpi, and after you change the resolution, then you can calculate the pixel size value. And here's a formula how you can create. And we have done few of them, and then we average the pixel resolution and pixel size value, and we came to the conclusion of 20 micron. So after you have that information, then what you do is you create a table with the camera information and the frame data or exterior orientation table. And then this table you save in a CSV file format. And if you want to know more information, you can get it from Arcgis Pro site. So then what we have done is we use the Arcgis Pro, and the Arcgis Pro has a really nice module which will allow you to create orthomosaic image from historical scan images or any the scan images, aerial photo scan images. So you go through that process. That you say give the workspace name, and then select the type of images that you are going to use. And in our case is the scan aerial photographs. And after that, you feed the exterior orientation table that I have created, as you have seen in the earlier one. And then the camera information. Once you have done that, the next part that you have to do is you have to give elevation data information in order to create the orthomosaic. So after that is done, then you click on finish. And what it does, it creates a collection of images together. After the collection of images is created together, then what you have to do is you go through another workflow. So the first thing what you have to do is you have to refine the interior orientation by selecting the fiducial mark of each one image first. And then after you select the fiducial mark, and then what you do is you compute the fiducial mark coordinate system for all the images that you have listed in the table. And after that is done, then what you do is you update the interior orientation part. After both of them ran successfully, then what you have to do is you have to do a block adjustment. So then all the images will be adjusted properly. Then if that process worked really well, then you could actually create the orthomosaic. But what we have done is, in order to get a better spatial locations, we also use ground control point and tie the ground control point using the recent imageries. And then after that is done, then again you run the block adjustment again. And after that is done, then we created the orthomosaic. So I will show you the result of that one. So also at the same time, I just wanted to give you a little bit information about the 1943 aerial photographs. So 1943 aerial photographs printout looks like this, and it was already scanned by some student before. Maybe this is done 7 or 8 years ago. So the problem that we have found, these images using the Ortho mapping product, is that if you have a lot of fiducial marks like this, it might confuse the software. So what we have to do is we have to clip this image and cut it like that. So then whatever the fiducial marks that we have registered will be recognized easily within the software. So that is done. The one thing that I wanted to say is 1943 aerial photograph printhouse has a lot of scratch marks. So because it was old, and so that's the one issue that we have found with the 1943 aerial photograph. Now, this is one of the flight maps, and as you can see that the pilot is not flying in a straight line. They are going down, they're going up, and so forth. So it's a bit challenging in first trying to register them properly, and in order to get the center of the aerial photograph itself. So then after that is done, then the workflow is almost the same as which I described earlier. Then what you have is you create the orthomosaic. This is one example of orthomosaic created around this town. And so this is the example of 1943, the 1970 orthomosaic, and then the same place, as you can see in the QuickBird image that we have purchased in 2005. You can see this one. And this is the Esri imagery. And I checked the date, and its date seems to be June 2019. So just show you the final result of one of the products that we have is, as you can see, this path is visible in 1943 images, but hardly any dwellings are here. And that is one of the challenges that we found when we're trying to do traditional georeferencing, because there's hardly any feature that we could recognize easily. So you can see this particular line is still visible, right? And so that tells you that the orthomosaic workflow that we have done seems to be working really well. So we are hoping to go through all of them. And after that is done, then we will use other tools to extract the feature. So before I finish, I want to acknowledge some of the help I've received over the time. Like since 2015 onward, I was trying to explore to process this historical aerial photograph, and these people have helped me and also helped me to use the ortho mapping tools. And I found these tools really good to process the historical aerial photograph. Okay, thank you. And if you have a question, ask me. Thanks a lot.